Hello everyone, welcome to 6.1, which deals with adding and subtracting polynomials. So the goal of this section is to identify what is a polynomial and what are monomials, binomials, and trinomials, how to determine the degree of a polynomial, and then how to add and subtract polynomials, and then evaluate a polynomial for any given value. So let's start. So first of all, remember what we said, that a term was a constant or product of a constant and or one or more variables. So when you have a monomial is also another word for a term, right? So you have here 8, negative 2x squared, 4y cubed, and 11 z to the power 7. And the book defines a monomial as a term of this form ax to the power m, where a is a constant and m is a positive whole number. So basically, monomials are, all the numbers are monomials. And honestly, a monomial can also have multiple variables. It doesn't necessarily have to have one variable, but in this book it does define it that way, which is fine. But okay, so anyway, a polynomial is obviously many monomials being added or subtracted together. So polynomial is kind of like everybody, right? And if you have one term, it's a monomial, one term. If you have two terms, it's a binomial. So here's an example of a monomial. So a monomial would be like x or y or x squared or 5y to the power 3 or something like that. And then a binomial, and it has exactly two terms. So an example with that would be x plus 3, 4x plus 1, x squared minus x. So these are binomials. And then trinomial, you guessed it, has exactly three terms. So like x squared plus 2x plus 1, or 3x cubed plus 2x plus 1. So three terms, 1, 2, 3. Okay, so let's define degrees. So degree of a polynomial is the highest power of a polynomial, okay? So one way to think about it, so let's say here you have a monomial of 14, the highest power, when there's no variable, the degree is 0. Now 8y squared, the degree would be 2. So if let's say you have a monomial that is 9x cubed y to the power 6, so see, there you go. They add the degrees together, and that would be 8 for that term. And if you have a binomial, so these are two terms, two terms, two terms, two terms, the highest degree here is of that monomial is 1. This degree is 2. This is a 1. This one has 2 squared, but they're multiplied, so that's why it's degree 4. And then this one is a 3, and the degree of this is 3. The degree of this is 2, but the highest degree is 3. And then trinomial, the highest degree is 2, so the degree of that polynomial is 2. This one, the degree of this polynomial is 2. The highest degree would be 6, which is this one. Here, this one is 4, so the degree of this polynomial is 4. Okay, so basically any polynomial. So technically, like all these are polynomials, but they're specific kinds, right? Okay, so this would be a squared. This is to the power 4. This is to the power 1. Okay, so let's first talk about how do you tell if a polynomial is a monomial, binomial, trinomial, or just polynomial, right? So this case for A, you have 1, 2, 3 terms, so trinomial. And then this one is just one term, monomial. Okay, this one has 1, 2, 3, 4, 5 terms. We're just going to say polynomial many, right? Okay, this one has 1, 2 terms, so this is a binomial. This one here is one term, monomial. This one is, again, so let's go down here, one term, monomial. Okay, this one here is 1, 2, 3, 4. So more than 3, we just say polynomial. Polynomial. This one has 1, 2, 3, so trinomial. This one has 2 terms, so binomial. This one has 1 term, so monomial. So you guys kind of get the gist of it? All right. What about adding and subtracting them? So basically that's just like terms, yeah? Remember we talked about like terms? You can add or subtract monomials when the coefficient, when the variable part is exactly the same exponents, okay? Then you can go ahead and add or subtract. So like here you have 25y squared plus 15y squared, so that's going to be 40y squared. So then here you have 12q squared plus 9q squared, that's going to be 21q squared. This one is negative 15c squared plus 8c squared, so they're different. So we're going to subtract, but then we keep the sign of the larger, so that's going to be negative 7c squared. Then if we subtract these two, we're going to, remember if subtracting a negative becomes positive. So 16 plus 7 is going to be 23p. So then what about this one here? We look for 2 terms that are alike, or more terms that are alike. So here, the first term, we have c squared minus 6c squared, so that's negative 5c squared plus 7d squared, because we can't combine the c's and the d's. So then let's see here, we have 8y squared plus 3z squared minus 3y squared. We can only combine the y squared terms. So this is going to be 5y squared. And we can't combine the z, so we leave that there. So 3z squared. So then here we have u squared v plus 5u squared minus 3v squared. So we can't combine any of these. So that would just be, we just leave it that way. So that would be, u squared v plus 5u squared minus 3v squared. So we just leave it that way. So then similarly, this one, we can't really combine them, so we leave them as is. Pq squared minus 5q squared minus 6p. So then here, when we're adding polynomials together, it's the same thing, right? We're just combining like terms. That's all we're doing. So then here, let's do an example. So here we have 5y squared, and then we have 3y squared. So together it's going to be 8y squared. We're done with that. So then we have a negative 3y and a negative 4y. So together it's negative 7y. And then we have 15 minus 11. So that's going to be positive 4. And then here, to find the difference between two polynomials, you need to distribute the negative because it's as if you're multiplying by negative 1. Okay, so let's rewrite that. So that would be 9b squared minus 5b minus 4 minus 3b squared plus 5b plus 7. Okay, so let's go ahead and circle the like terms. We have 6b squared. Then this negative 5b and this positive 5b will cancel each other out, right? Because they're opposites. And then you have negative 4 plus 7, and that becomes plus 3. Okay, so let's go ahead and do a couple more. So when you subtract something from, when you're saying, okay, subtract 5z squared minus 6z minus 2 from 7z squared plus 6z minus 4, that means that this term comes first. And this is the second, okay? So 7z squared plus 6z minus 4, and then we're subtracting 5z squared minus 6z minus 2. And then we distribute that. 7z squared plus 6z minus 4 minus 5z squared plus 6z plus 2, right? Because we're distributing the negative. And then we combine like terms. So then we just look at which ones are the like terms. So then it would help to just underline them or draw a box or whatever it is that's here. So like here, the z, you see the z squared terms. So we combine that and that becomes 2z squared. Okay, and then we'll have here, let's see, 6z plus 6z. So then that's going to be a plus 12z. And then the last terms would be negative 4 plus 2. So then that would be negative 4 plus 2, which becomes minus 2, and then you're done. Okay? So, so that's helpful, you know. So then we have, let's go ahead and distribute and see what we have here. So we have a cubed minus a squared b. Then distributing this negative, we have minus ab squared minus b cubed plus, and then, you know, when you have a plus in front of parentheses, you could just get, you know, just write it that way. Plus ab squared. So then we have a cubed, right? There's no other a cubes. Okay, fine. Then we say, okay, I have an a squared b here and an a squared b here. They cancel each other out because one's positive and one's negative. That's fine. Then what else do I have? I have a negative ab squared here and a positive ab squared here. So they also cancel each other out. So then finally, I'm just left with the minus b cubed. So that's it for this one. Okay, and then the last thing that you want to do is be able to evaluate a polynomial for any given value. What does that mean? That's just a fancy way of saying, hey, instead of the letter, replace it with the number that I'm assigning to that variable. Excuse me. So let's say here we have 5x squared minus 8x plus 4, and then x is equal to 4. So we have 5 times 4 squared minus 8 times 4 plus 4, see? And then we just solve that using order of operations. We have 5 times 16 minus 32 plus 4. And then 5 times 16 is 80 minus 32 plus 4. So what is 80 minus 32? 80 minus 32, going from left to right, 48 plus 4, which is going to equal 52. Okay, so that's the first one. And then let's go ahead and try the next one, negative 2. So we have 5 times negative 2 squared minus 8 times negative 2 plus 4. Okay, this is actually the same exact things pretty much, except it's a different variable. So I'm going to get rid of this one. Plus I need space to write. Okay, so then order of operations, that's going to be 5 times, and the negative 2 squared is positive 4. And then this negative 8 times this negative 2 is positive 16 plus 4. So this is going to be 20 plus 16 plus 4. So that's going to be 36 plus 4, which is 40. Okay. And then finally, so this was B, this was A. And let's go ahead and do C over here in another color. So then we're plugging in 0 for X. So 5 times 0 squared minus 8 times 0 plus 4. That's going to be 0 minus 0 plus 4. So your answer is just 4. Okay, so we really like that when it's negative. Okay, so that's it for 6.1. Let me go ahead and do either odd or every other odd, sorry. And good luck and happy studying, and I will see you in the next video.